బాగుందా ఇది? ఏమైనా చేంజెస్ చేయాలా?
I have opened again.
Okay, sir. Okay, start, sir.
Very good afternoon to all. I hope everyone is doing well and safe. Sorry for the inconvenience. There was some technical glitch. That is why the organizers were taking a bit of time in order to settle down the things. Right. So let me share my screen. Hope you are able to see my screen. All right. And
Yes,
my voice
yes.
is audible to.
Yes, yes, audible.
Yeah. Fine. So let's get back to the discussion. So, right, let's have a recap of what we have saw till now, and we'll continue from that, right? So, ab-
1 minute.
yeah, about this course of EV engineering. The first day, we actually tried exploring the opportunities that are there in EV industry. How is the future of electric vehicle in India? We can make our youth clear for the growth of economy and for growth of our country, right? And what is the vision for Atmanirbhar Bharat, and how we can upskill ourselves for becoming the self-reliant India, for making self-reliant India, right? So these are the few things that we saw. Then we saw the need of fostering education and employability. We saw the automotive industry before and with COVID. What are the challenges? What is the Indian automobile industry need for electric vehicles? Transportation system overview we saw, then roadmap, classification, evolution, investments, requirement for renewable energy sector. Then we saw the need of EV ecosystem, different types of from gasoline to hybrid, plug-in hybrid, electric vehicle, fuel cell vehicle, right? Then we saw the emissions from different modes of series hybrid, parallel hybrid, hybrid, hybridization levels, EV systems, subsystems, distribution weight classification, comparison of EV, e-mobility in India, then future of mobility in India, National Electric Mobility Mission Plan, electrification approach, global EV market, Indian EV market, driving factors, different products of Indian mobile and EV industry. Then we saw about the different propositions that will be emerging in coming time. Right? Then we saw about motor battery controller, the types of motors, what are the characteristic of motors. Then we saw about a few of the case studies of different types of motors. We saw the case studies of different types of motors, right? Then what else we saw? We saw about the motor principle, how a motor functions actually. right? Then we saw about the different types of motors, right? So we stopped till this point actually, right? So let's try to resume from here and let's try to understand. So yesterday we were discussing about one part, right? I hope everyone is clear till now. Everyone is clear till now, right? If you have any doubt, if you have any clarification, you can just post your query or thing in the chat box, right? So yesterday we were discussing about one thing, how a motor can act as a generator, right? How a motor can act as a generator. And I told you that in today's session I will show you a video where you can actually understand how a motor can act as a generator, right? So there are two things, yeah, there are two things that we have to understand. Motor construction or generator construction, both the constructions are similar because both are working with the magnetism concept. Both are working with the magnetism concept. And when we see about motor, in motor there is a stator, there is a rotor, like that, and in generator also, if we see, there is armature, right? And all these things. So if we understand, that in motor or generator, what we are trying to do, we are trying to do the interaction between the stator and rotor magnetic field, and that is how, because of that interaction between the stator magnetic field and rotor magnetic field, the rotor is moving and we are getting a torque or output or something like that, right? So if we see RMF speed, what is RMF? Rotating magnetic flux that is getting created, right? So if RMF speed, right, is greater than our rotor speed, if RMF speed is greater than our rotor speed, then the motor will act as a then the setup will act as a motor, right? And when the RMF speed is lesser than the rotor speed, yeah, when the speed of RMF, like the RMF speed is lesser than the rotor speed, then it will act as a generator. It will act as a generator, right? Uh, Tarun, I think you commented that please start the class. I think the class already started, and I hope you are able to hear me what I'm trying to communicate, right? Everyone is able to get what I'm telling. Yes. Yes, Shankar. Right. So this is what about this thing. So let me show you a video which you can understand. It, yes. So here you can understand how the regenerative braking is happening, and how the motor will act as a generator. How a motor can act as a generator? You see, there are two concepts. One is RMF speed, another is the rotor speed. So the setup will act as a motor if RMF speed is greater than the rotor speed, and it will act as a generator if the rotor speed is greater than the RMF speed. I hope through this video you will be very clear with the concept, right? All right. So this was a thing about the rotor speed and the RMF speed and how motor can act as a generator. Right now, let's try to understand. Let's try to understand uh, the further things that we have to discuss today. Right. So about the types of motors, right? About the types of motors. So when we say a motor or a traction motor that we are going to use for our electric vehicle, we have to actually understand what are the different types of motors. What are the different types of motors? So yeah, so hope you are able to see the screen, my screen. Yeah. So electric motors are majorly categorized into three types. Electric motors are majorly categorized into three types, right? DC motors, AC motors, and other motors. So in DC motors, there are different types. So DC shunt motor, separately excited motor, series motor, PMDC motor, compound motor. Yes. So this is what these are what the different types of DC motors. These are what the different types of DC motor. Right now, let's try to understand what are the motors, what are the DC motors that are specifically used for electric vehicles. Right. Will in coming slides we'll see what are the specific types of DC motor that are used in electric vehicles. Right. So first, try to understand the overall classification of electric motors. So electric motors are divided into or categorized into three types: DC motors, AC motors, and other motors. So in DC motor, DC shunt motor, separately excited motor, series motor, PMDC, compound motor. Then in AC motor, induction motor, synchronous motor. Then in other motors, it comes the stepper motor, brushless motor, hysteresis motor, reluctance motor, universal motor. Right. So in DC motor, what is the difference between this DC shunt motor, separately excited motor, series motor, compound motor? Here, in these different types of DC motors, in these different types of DC motor, right? The only difference, like the difference between the shunt motor, series motor, compound motor, is the position or configuration of you know the field and armature. So let's try to see that thing. Right here you see the field is connected in series. It is in a shunt position. Here it is in a compound position. Are you able to understand? I hope you are able to understand. Yes. So these are the different configuration. Yeah. Shunt is nothing but parallel. Series is series. Compound is combination of both series and parallel. When we say that the resistor is shunted, it means the resistor is connected in a parallel configuration. Right. So I hope everyone is aware about series and parallel. Right. So in coming slides, when we are discussing about battery, we are actually going to see the difference between connecting the cells in series, connecting the cells in parallel. Right. So all right. So yeah, so let's try to see specific about the motors. Right. So these are the different types of motors. These are the different types of DC motors majorly used in our electric vehicles. Right. So yeah, and Shankar Narayan is asking that what is that F1 F2. So F1 F2 is nothing but field. You see, this armature and field. We represent that armature, right, or the rotor with that M. Right. Are you able to understand? So these are the notification where what we give for armature, and this F is the field. So here the field we are connecting in series as well as parallel. That is how that is F1 F2 you are able to see. So now let's try to understand. Yeah, field winding, correct, the field winding. Yeah. So now let's try to understand about the different types of DC motor majorly used in our electric vehicles. So in our electric vehicle, we can see the brush DC motor, we can see the PM DC motor, permanent magnet DC motor, and we can see the brushless DC motor. So can you tell me what is the difference between these types of motors? What is the difference between these types of motors? So can anyone explain? You can use your mic, or else you can comment in the chat box. You are free to respond. So can you tell me what is the difference you are able to see between the brush DC motor, permanent magnet DC motor, and brushless DC motor? Yes. All right, so let's try to understand the difference. Right here, in brush DC motor, right, you see the construction wise, stator is electromagnet. There are poles on which the winding is there, the field winding is there, right? The stator here in brush DC motor that you are able to see on the screen is electromagnet. There are poles on which the winding is there, and current is being passed through the winding, so that it will become electromagnet. So this electromagnet, or the stator, will be creating its magnetic field. Now you see, for the armature, right? For armature, there is armature core and armature winding, and current is being passed through the armature winding, where the armature windings are connected here through the commutator brush. So brush here are for electrical contact purpose. Brush is made up of what material? Brush in motor will be made up of what material? Yes, carbon. So yeah, exactly, carbon. So here, this carbon, being a conductor of electricity, that is used here as a electrical contact purpose, right? So it is connected here with the commutator and all the other setup. So that is how the current is being passed through the armature winding. And when the current is passed through armature winding, the armature will also become an electromagnet, and it will also create its magnetic field. And when it creates its magnetic field, the magnetic field of stator and rotor they both will interact with each other, and because of the interaction of the stator magnetic field and rotor magnetic field, there will be the torque generated, or the twist will happen, and that's how the rotation of the motor shaft will happen, right? And that is how we are extracting the mechanical power from our motor. I hope everyone is clear. Yes. So in similar way, the functionality, or the execution will happen in permanent magnet DC motor as well as BLDC motor, right? Here in permanent magnet DC motor, what is the difference between the images that you are able to see on the screen, like brush DC motor and permanent magnet DC motor? What is the difference you are able to see between these two types of motor, this motor and this motor? What is the difference? Yes, please. Yes. Stator and rotor. What is the difference? Chittori Kumar. Chitturi Kumar. Subhash Chandra from C.R. Reddy College of Engineering is telling that in place of field winding, permanent magnets are placed. Right. The difference that you are able to see on, between the two motors that you are able to see on the screen, this motor and, this motor, brush DC motor, and this permanent magnet DC motor is here in brush DC motor. In brush DC motor, sorry, in brush DC motor, the stator is electromagnet. In this motor, the stator is electromagnet and the rotor is also electromagnet. Whereas in permanent magnet DC motor, the stator is permanent magnet and rotor is electromagnet. Are you able to understand? Are you able to understand? Yes. Here in permanent magnet DC motor, the stator is permanent magnet and the rotor is electromagnet. And through the this windings of the electromagnet, right, the current will flow and it will generate the magnetic field, and that is how the interaction between the permanent magnetic field and the interaction between the magnetic field of the permanent magnet and the rotor will happen, and that will create the motion, right? Right. So that is what happens here for permanent magnet DC motor. Now can you tell me what is the difference you are able to observe, that you are able to observe between the brush DC motor and brushless DC motor? Brush DC motor and brushless DC motor. Yes. What is the difference? Brushes are absent. Okay, brushes are absent. Only that difference you are able to observe, Chitturi Kumar? Yes. Yes. See, let me tell you, these are very key questions. Okay. In your interview, the interviewer will not ask you to completely design the architecture or design the whole motor construction or something like that. They will ask you very simple and simple questions. What is the difference you are able to see between the brushless DC motor and brush DC motor? Right. So there is very simple difference. There is very simple difference, and I suggest you that everyone should actually understand the concept very very clearly, because once the concept is clear, then only you will be in a position to answer properly in your interviews, also in your further discussions, in your group discussions, whatever it is. Because understanding is the key factor for reflecting. If the bottle is full, then only we can pour the water in glass. Correct. So like that, we have to understand that we have complete understanding of our engineering discipline, right? Yeah, let me tell you. So the difference that you are able to see between the brush DC motor and brushless DC motor is, in brush DC motor, in the image that you are able to see on the screen, the stator is electromagnet, the rotor is electromagnet. Whereas in brushless DC motor, stator is electromagnet and the rotor is permanent magnet. Rotor is permanent magnet. Why we are passing electric current through the rotor here? Why we are passing electric current through this armature winding or rotor here? We are passing electric current through this armature winding or rotor here to make it electromagnet, so that it will create the magnetic field, so the whole reason to flow to have the brushes here, is to have to flow the current through the armature winding. But understand, when we are replacing this armature winding or armature, by a permanent magnet itself. You see here, the rotor is permanent magnet. In spite of this armature winding, these brushes, everything, we are replacing that with a permanent magnet. So there is no need of brush here. There is no need of passing electric current to the rotor here, because rotor is already a permanent magnet. Already it is creating magnetic field, and that magnetic field is interacting with the stator magnetic field produced by the stator because of the flow through the windings of the stator, right? So that is how here we are, there is no need to have the brushes, and that is how the BLDC motor is generating the required power and torque. So there are disadvantages of brushes, like brushes, they get wear and tear, right? They get wear and tear, and brushes, they are, as they are made up of carbon, so this wear and tear will happen, and this may lead to the maintenance. Sparks might come, so sparks will come, maintenance, wear and tear, and size will also increase, and that is why the weight will also increase. So like that, many disadvantages are there for our brushes. So that is why people are now going for brushless DC motor. Here someone has given one question, so I will try to, if many questions are there, I will try to answer it at the end, but I think only one question I am able to see in the chat box, that is related to the brushes. So Shankar Narayana is asking that, will the brushes be purely carbon, sir? So see, brushes, actually the function of the brush we have to understand, right? The function of the bus is to brushes here to provide the the electrical contact. So these brushes are made up of carbon and graphite. So there's a carbon graphite material that is used, right? And major component here will be of graphite, because it is having low friction, right? And when we go for large motors, so for small motors we can have the graphite itself, or we can have the like entire graphite for brushes. But when we go for large motors, we have to use a mixture of graphite and copper. I hope this answers your question, Mr. Narayana, right? So yeah, right. So let's move to the next part. So these are the different types of DC motors we saw. So now let's try to understand what are the different types of AC motors we can see in electric vehicles. So we can see majorly, three-phase AC inductions getting implemented in major of the electric vehicles. So the reason why people are switching towards AC motors, or the reason why people prefer AC motor, can you tell me what is the reason why people try to prefer AC motors? Yes. Yes. So what happens actually in DC motor? Right? In electric vehicle, whether we are using AC motor or DC motor, our objective is to control speed, right? to control, like to provide the power, to provide the torque, to provide the rpm, right? So rpm or the speed is one of the intention why we are utilizing these motors, right? So speed control in DC motor and speed control in AC motor, if we compare both the things, so in DC motor the speed control has to be happen through armature control, field control, like that. Whereas in AC motors, you know, very easily we can change the speed by changing the frequency, by changing the frequency. So here I will show you a very kind of effective through which you can understand the AC motor functionality and all this. Here there are different three motors you are able to see on my screen: single phase induction motor, three phase induction motor, and synchronous motor, right? So the construction wise the single phase, three phase will be similar. The difference will be of the phases, like single phase and three phase, and the functionality, right? And in synchronous motor, the synchronous motor runs at a synchronous speed, at a constant speed of what we call synchronous speed. So working of synchronous motor depends on the interaction of the magnetic field of the stator and with the magnetic field of the rotor, right? So the stator contains three phase of windings and is supplied with the three phase power, right? So three phase of winding of stator is supplied by the three phase of power. Thus stator winding, they produce three phased rotating magnetic field. They produce three phased rotating magnetic field, right? So yeah, so the rotor enters the rotor in the synchronous motor, right? Let's try to understand what I'm trying to communicate. So in synchronous motor the stator is having three phase windings, and these three phase windings are supplied by the three phase power. And because of that power, the the magnetic field, the rotating magnetic field is getting created, and the rotor enters into that rotating magnetic field produced by the stator windings and rotates in synchronization. It rotates in synchronization, right? It rotates in the synchronization. That is how the speed of motor depends on the frequency of the supplied current. Here the speed of motor depends on the frequency of the supplied current, right? So this is what about synchronous motor, this is what about synchronous motor, right? And can you tell me what is the difference between single phase and three phase? Can you tell me what is the difference between single phase and three phase? Chittori Kumari, Chitturi Kumari, you're trying to write something in the comment box, but I'm not able to get what you are trying to communicate or what you are trying to, tell us. All right, can you tell me what is the difference between AC single phase and three phase? All right, uh, let's try to make it very simple. Let's try to make it very simple, right? Can you tell me, right, which motor is self-starting, single phase or three phase? Can you tell me which motor is self-starting, single phase motor or three phase motor? My question is very simple. Which motor is self-starting, single phase or three phase? Telling three phase, if you are telling single phase. Have you heard about double field revolving theory? Have you heard about double field revolving theory? Are you people aware about double field revolving theory? Yes. Are you aware about double field revolving theory? You can say yes or no in the chat box. Yeah. So double field revolving theory, it actually explains about the single phase induction motor and the working principle of single phase induction motor, and it actually clarifies why single phase induction motor are not self starting, why single phase induction motor are not self starting, right? And so when I ask the question, what is the which motor is self starting, single phase or three phase, so the answer is, self starting motor is three phase induction motor, single phase motor is not, single phase induction motor is not self starting. Okay. Another question is, have you ever seen what motor is there in our ceiling fan? What motor is there in our ceiling fan? What motor is there in our ceiling fan? Induction motor is correct, but what type of induction motor? Chitturi Kumar, you are telling that in our ceiling fan there is an induction motor. What induction motor, single phase or three phase? Yes, it is a single phase. Right. So in our ceiling fan, we use single phase induction motor. That is very true. That is very correct. Very nice. Those who have given this answer, very good. Now, my question is, have you seen, the wiring or the connection for this our ceiling fan? Along with our ceiling fan along with our ceiling fan, there will be a cylindrical thing that will be connected. What is that actually? Capacitor. Yes. Yeah, so you are correct, Mr. Shankar Narayana. That is capacitor. So we connect capacitor with our single phase induction motor. So what is the need of capacitor? What is capacitor actually? Capacitor is active device or passive device? Yes, Mr. Shankar Narayan is telling that capacitor is for storage of charge. Yes, very true, Mr. Shankar Narayana. Capacitor is for the storage of charge. So can you tell me why we are connecting capacitor here with the single phase induction motor? Is it to store the charge, or what is the purpose? Yes, what is the purpose? Yes, few people are commenting. Correct answer. Subhash Chandra from CR Reddy College of Engineering. Very correct, Subhash. You are telling that capacitor we are connecting to create the phase difference, phase shift, correct? So, what is the phase shift created by capacitor here in our ceiling fan? What is the phase shift created by our ceiling fan here? Sorry, capacitor in ceiling fan? See, daily we are using ceiling fan. Without fan, few people cannot sleep also. In winter also, they have to at least switch on the fan. They will hear that noise or the voice of fan, then only they will sleep. But being an engineer, we should actually understand how it functions. How it functions, right? How it functions, we have to actually understand that, right? And we have to see, okay, the things that are happening in and around us, how it functions actually, because based on these things only, right, we will explore the things and we will be able to come up with some solution for our society. Yes. So can you tell me, capacitor, it allows AC or DC? Capacitor, it allows AC or DC? Why it allows AC? Yes. Why it allows AC? Those who are telling why it allows AC. Right. Let me tell you when we, yeah, so actually we were discussing the topic of AC motors. So the AC motors that we use for electric vehicles, so in that we were exploring single phase induction motor, three phase induction motor, and synchronous motor. We saw what is synchronous motor, how it functions, right? So in synchronous motor there will be three phase supply for the stator, and this stator will be creating a three phase rotating magnetic field, right? And in that rotating magnetic field the rotor will be rotating at the synchronous speed, and here the speed of the motor will depend on the frequency of the current, right? Now we are discussing actually the difference between single phase and three phase. So the difference between the single phase and three phase motor will be the, of the phases, right? So in single phase there will be only one phase, and according to the double field revolving theory we can actually understand why single phase induction motor is not self starting, right? So for starting this single phase induction motor, we use capacitor. The reason of the capacitor is, right, to create the phase difference. So not only capacitor we can use any phase creation element, right, to create the phase difference so that our single phase induction motor can become self starting, right? So in three phase induction motor it is already self starting, right? And we saw the reason why people are heading for induction motor is that in induction motor the control of the speed of the motor is depend on the, current, by changing the frequency of the current, right? By changing the frequency of the current, by changing the the current frequency, we can easily change the speed of the motor, right? Here now let's try to understand the role of capacitor, right? We are discussing the role of capacitor. So capacitor is used to create the phase difference, that is very true. Now my question was, why capacitor allows AC? Like my first question is whether capacitor it allows AC or DC. Can you tell me whether capacitor allows AC or DC? Capacitor it allows AC or DC? Okay, people are telling that it allows AC. Yes, why it allows AC only? I will tell you one story. I will tell you one story. I asked this question. I asked this question to few of the people, saying that tell me whether capacitor it allows AC or DC. Capacitor it allows AC or DC. So he told he thought for a while, and he told okay, capacitor it allows uh, AC. I told okay, can you explain with some mathematical explanation, or can you give some equation, or something like that, to understand why capacitor it allows AC, and why it blocks DC. So he told I need to recall. He told that his faculty means is in his class, the faculty was teaching electrical engineering. He told some explanation or something like that. So I told okay, fine, you can think for a while and you can tell us what is the explanation or something like that. Are you able to see on my screen a capacitor symbol? Are you able to see on my screen the capacitor symbol? Yes. Now the explanation that student gave is, he told me that in DC, in DC, the power supply or the flow will be constant. There will not be any variation, right? There will not be any variation of the voltage with the time, right? So it will be constant. Correct? Am I right? Am I right? There will be constant voltage, right? It will not vary with the time. Yes. But in AC, what will happen? In AC, there will be variations. There will be variations with time. There will be variations with time. And he told that capacitor, it allows AC. Capacitor, it allows AC because AC can pass through it like this. AC can pass through it like this. And DC, when it comes, there is no way to pass because there is space in between, or there is flaw in between, like that. So DC cannot pass. AC can pass like this. So I was wondering, this might be a technique or some good way of remembering the thing that faculty might have taught, but he considered this thing itself as an explanation. Are you able to understand? Are you able to understand? So you should not be in the same position saying that capacitor, it allows AC because if it pass through like this, it can pass through like this. DC cannot pass, right? Because being an engineer, we should actually understand why capacitor, it allows AC and it blocks DC. So everyone is aware about XC. XC is nothing but 1 upon 2 pi FC, right? XC, the reactance here, capacitive reactance, is XC is equal to 1 upon 2 pi FC. And we know that for AC, the frequency is, let's suppose 50 hertz. So here the frequency will be 50 hertz and into C. So the reactance value for AC supply or AC input will be a finite value. Whereas X DC will be 1 upon 2 pi 0 into C is equal to 1 upon 0 is equal to infinite. Are you able to understand? Are you able to understand? Yes. So this is what a mathematical explanation, a mathematical understanding why capacitor, it allows AC and it blocks DC. When the resistance is infinite, how it will go? It cannot go. It will not go, right? So yeah, that is what I'm trying to communicate. So it is our responsibility to understand things, to learn things, and to apply things, also, right? So now we can see in electric cars, in electric vehicles, right? Both DC motors as well as the AC motors are being used. So there is efficiency of these different types of motor. So through induction motor, people are able to extract efficiency up to 91%. For brush DC motor, they are able to extract the efficiency up to 80%. For BLDC motor, up to 93%, right? And if we are using any DC motor in our electric car, please take a note, I am talking about electric car. If we are trying to use any DC motor for our electric car, we are using any motor between 96 volt to 192 volt. And if we are going to use any AC motor for our electric car, then we are choosing the voltage system between 240 volt to 300 volt, right? So this is about the different types of motors and all these things. Now we are going to start our discussion about selection of our motor. What is the procedure to select a particular motor? What are the calculations involved in it? And what are the things we need to actually consider? And just for confirmation, I'm asking. I hope everyone is clear till now. Any doubt, anything? Please do comment. Please, stop me and let me know if you need any clarification or something. Yes. Now let's try to see the motor selection part. Everyone is clear? Yeah. Now let's try to understand the motor selection part. So motor selection is very, very important. How we are going to select the motor? For selecting the motor, the first thing that we need to consider is application. Application. Based on the application, we are going to select these 6 parameters. We are going to select these 6 parameters. What are they? They are motor type, right? Motor power, motor voltage, motor cost, motor size, and motor performance, right? So how to understand what is the application? Application we have to understand by exploring where we are actually going to use that thing. Let's suppose, take an example of electric bicycle. Take an example of electric bicycle. So I have to use my electric bicycle. For what purpose? I'm going to use my electric bicycle for my personal commute from my office to my home and from my home to office. That is what my application is. So for that purpose, we have to understand the characteristic of both the types of motor, AC motors as well as DC motors, and from that we have to select AC motor or DC motor, right? Okay, so for application like bicycle, for application like scooter, for application like bike, we can easily utilize DC motors. Brushless DC motor we can easily utilize. For applications like car, for applications like buses, applications like load carrying vehicle, LCVs, and all these things, we have to go for AC motor for efficiency, for reliability, and for precision, right? All these things will come into consideration, and for that purpose, now we have to understand the application. Based on that, we'll select the type of motor. Now let's suppose for my electric bicycle, I have decided to go for DC motor. Now in DC motor also I have to decide the type of DC motor, whether I have to go for brush DC motor or I have to go for brushless DC motor. So I see the brushless DC motor gives the better efficiency, compact size, and it is more reliable. So I will go for brushless DC motor, right? So everyone is clear till now. First I have to decide the application. Based on the application, I will select the AC motor or DC motor. Let's suppose I have selected DC motor. Then in DC motor, I have to select permanent magnet DC motor or brush DC motor or brushless DC motor. So I have selected brushless DC motor. Everyone is clear? Yes? Yeah. So now the next thing that I have to select is the power of the motor. What should be the power of motor? Whether I have to use 500-watt motor or 1 kilowatt motor or 2 kilowatt motor or 3 kilowatt motor. How to decide that? We have to decide that by understanding where the power consumption is happening. So when a vehicle moves, so there are 3 types of resistances that we have to overcome. 3 types of resistances that we have to overcome. What are they? They are rolling resistance, gradient resistance, and aerodynamic drag. Rolling resistance, gradient resistance, and aerodynamic drag. So these 3 types of resistances we have to overcome. So for overcoming these 3 resistances or these 3 powers like gradient power, aerodynamic drag power, and what else, rolling resistance power, we have to have our motor that is providing the required power to overcome these resistance powers, right? So we have to actually calculate these different resistances like gradient resistance, rolling resistance, aerodynamic drag resistance, and accordingly we have to select the power. Okay, accordingly we have to select the power. All right. Now, the next thing is voltage. How to select the voltage? When we know the power, we have to actually understand, okay, this is the power. What should be my ideal voltage, suiting to my, suitable for my requirement? So that thing we have to calculate, right? So power we have to calculate, voltage we have to calculate. What should be my suitable voltage, right? Let's suppose for my electric bicycle, I decided for DC motor, I decided for BLDC motor, I decided a power of 250 watt. Then I have to decide what should be my voltage, like 250 watt, 36 volt, 250 watt, 48 volt, what it is, right? So based on our calculation, based on our insights, based on all these things, we'll decide, like DC motor, BLDC motor, 250 watt, 36 volt. Now we have to understand the cost parameter. What is the cost, right? If my electric bicycle, I am planning to sell, at a cost of, let's suppose 25,000, and motor itself is costing around 10,000 rupees. Okay, so it will not be, suitable or feasible for me to execute it or proceed further, right? So after understanding the motor type, motor power, motor voltage, we have to see for the cost part. Right? And another thing, we have to see for the size part. Our motor must be as compact as possible. We cannot use car motor for our bicycle. Even if someone is giving me free of cost, I cannot use car motor for my bicycle. Can I use? No, right? We cannot use. So that thing, cost we have to analyze, size we have to analyze, and performance. What is performance of motor? How it is measured? Can you tell me what is the performance of motor? Have you seen any motor graph, motor characteristic, or motor graph? Yes, efficiency, okay. Right. So let me tell you, the performance of motor is majorly is there are various ways to actually measure the performance, like efficiency, torque, all these things. So we see two graphs actually. Power versus RPM, or power versus speed, we can say, and another graph is torque versus speed, or torque versus RPM. So these are the two very important graphs that we have to see. These are the two very important graphs that we have to see, and accordingly we have to decide whether we can go with this type of motor, with this motor, or not, right? So these are the selection criteria, these are the selection parameters, right? So now let's try to understand this selection and calculation part in a much better way, right? So let's try to understand a few of the terminologies that we will be using during the calculation. Let's try to understand few of the terminologies that we will be using during the calculation. So what is this thing, what is that, and all these things, let's try to understand. So we are going to use this letter or this terminology for mass. Here mass will be the total mass of the vehicle, inclusive of driver, load, chassis, powertrain, other components, all these things. Okay, let's try to take one example. Okay, for electric bicycle, for electric bicycle, can you tell me the what will be the weight of the bicycle? What will be the weight of bicycle, like all frame, motor, controller, battery, everything? Fifty kg, Chitturi Kumar telling 50 kg. Okay, you might not be having idea about bicycle, electric bicycle. Okay, take example of your Activa. Take example of your Activa. What is the weight of your Activa? What is the weight of your Activa? So here, if we are considering the weight of Activa, it will be, if we are trying to consider the weight of Activa, we have to consider the weight of tires, the transmission system, the engine, the body, right? Everything, even including the drivers, even including the driver and the person who is going to sit at back. So like that, we have to understand that m represent the total weight of the vehicle, including the driver and everything. So it is the total weight that we have to drive, right? The second thing is gear ratio. The second thing is gear ratio. So what is gear ratio? Let's suppose we have a motor. I hope you are able to see my screen. So we have a motor. This is motor M. Here is my drive shaft, right? Here is my motor and drive shaft, correct? Now let's suppose if I need 5000 rpm, if I need 5000 rpm, okay, or let's suppose I need 2000 rpm. Okay, let's suppose I need 2000 rpm. Okay, and my motor is able to deliver that 2000 rpm. So at drive shaft I need 2000 rpm. Okay, and my motor itself is able to give me that 2000 rpm. Okay, it motor itself is able to give me that rpm, right? So let's suppose here it is 44, right? Are you able to understand? Let's suppose I need 2000 rpm at my drive shaft and my motor itself is able to give the me the required rpm. Then there is no need of any gear reduction or this kind of alteration. There is no need of such kind of alteration, right? But let's suppose if I need more rpm, if I need more than 2000 rpm, more than 2000 rpm, and my motor can give 2000 rpm, in that case we can have a gear system or gear reduction or something like that in between, right? And here this gear ratio, like we can have the 6s to 1, 6s to 1, 8s to 1, 10s to 1, like that. That gear ratio will be in between, acting as a enhancement, right? So here this is what the the gear ratio is. Let's try to understand how this gear ratio or how this is happening in a car like Tesla. I'll Let's try to understand. Yes, so here you see the stator and rotor, right? Stator and rotor construction. So input power that is getting in, creating the rotating magnetic flux or rotating magnetic field, RMF. This you are able to see is the induced current. So here rotor speed is less than RMF speed. That is why it is functioning as a motor. Rotor speed is less than RMF speed. Here in AC induction motor, the speed is directly proportional to the frequency of the current. More is the frequency, more is the speed. Here, this AC type of motor, easily we can get a huge range of RPM. Whereas in engine, we are able to get a very limited range. Only up to, you see the graph, only up to 5000 RPM with less efficiency. Whereas here up to 18,000 RPM. That also in engine, the reciprocating motion has to be translated or transformed into rotational motion. We have to use the counterweights, right? We have to use DC motor for starting. We have to use flywheels, alternator, so many things. Whereas this AC motor is very simple and sweet. And if we compare the induction motor of Tesla, if we compare the weight, if we compare the power, and if we compare the weight to power, or we call power to weight ratio, we'll understand that this motor is far much better. And we'll understand what is the battery pack it is using. So Tesla is using lithium ion battery. they are using Panasonic cell. They are having alliance or MOU with the Panasonic, so they are using their Panasonic cells, right? So this motor will be connected. Motor will be connected to the through the inverter, because the battery is DC. The battery is DC. That is why we are using inverter. You see, in the battery there are different cells, single cells connected in series or parallel as per the configuration to form the battery pack, and in between there is a fluid flowing, coolant in, coolant out for, you know, thermal management. Around 7,000 cells are there in this Tesla battery. So this heat is going out. You see the ground clearance. You see the CG height. Structural support is given. So here is what the transmission that is happening. The transmission that is happening. See the motor output, the transmission output. Differential. Right? You see how the power is getting transmitted and how this differential is acting here. So ICE engine is having low response to the fuel cut, whereas here, as the fuel cut is happening, the motor will immediately, stop the flow of power. High response rate is there. Here in differential wise, if we see, the control is very simple here in electric vehicle. Only one pedal, one brake. Regenerative braking is also happening here. The kinetic energy of the car is getting converted into electricity during regenerative braking. Kinetic energy of the car is getting converted into electricity during regenerative braking. This is happening because the motor will act as a generator here. So here RMF speed is greater than rotor speed, that is why it is acting as an induction motor, and when the rotor speed is greater than RMF speed, it will act as a induction generator. and this is inverter. So generated electricity is fed there. Accelerator pedal and brake. That's it. So this is very simple and kind of thing that we can see in electric vehicle. And here you see there is huge crumple zone, right? Crush zone. There is huge crush zone, right? So yeah. So this is about the power transmission and how the electric vehicle is actually transmitting the power. And I hope this video have made many things clear. Have made many things clear. Yes. So now let's try to get back to the discussion that we were having with regards to our calculations. Yes. So m is the mass, gear ratio is represented by g. I hope everyone now got a clarity what gear ratio is and why we need that gear system or gear ratio, right? Then transmission efficiency. Transmission efficiency is with what efficiency the power is getting transmitted. So here majorly we are considering 80%, 90% transmission efficiency. So for our all calculations we'll take 90% as a transmission efficiency. Then comes the coefficient of rolling resistance. Coefficient of rolling resistance is nothing but CRR. What is CRR? CRR is nothing but coefficient of rolling resistance, right? It represent whenever the vehicle is moving on road. Vehicle is moving on road, it means the wheels are rolling on road. When wheels are rolling on road, there will be friction, there will be rolling of the wheels on road, and that rolling resistance is actually that what we consider. And when we consider that rolling resistance, for that rolling resistance we have to consider rolling resistance coefficient. So this is what that coefficient is. Okay, next thing let's try to understand. The next thing is vehicle frontal area. Vehicle frontal area is nothing but the frontal area of the vehicle. Let's suppose if the car is there and when the air is coming, right? So airflow is getting, kind of is the air drag is hitting the frontal area. So for considering the aerodynamic drag force, we have to consider the frontal area of the vehicle. So for rickshaw, it will be, that kind of frontal area. Let me show you. For auto rickshaw, this is the frontal area. For car, this is the frontal area, rectangular shape. For this is the frontal area. Are you able to understand? Yes. Yes. So AF represent vehicle frontal area. Vehicle frontal area, right? Then it comes the wheel radius. Wheel radius is nothing but the radius of the wheel that we are going to use here. So RW represent the radius of the wheel. Velocity at which we are driving the vehicle is represented by V. Alpha is the gradient inclination or angle. Alpha is the gradient. It is nothing but an inclination. And as I told you, in aerodynamic drag, when the air is coming and hitting to the frontal area of the vehicle or car, in that case we have to actually calculate the drag force. When we calculate the drag force, we have to use vehicle's drag coefficient CD. Please note down, when we are using or when we are calculating rolling resistance force, we are considering rolling resistance coefficient. When we are calculating vehicle's drag force, we are calculating where we are using vehicle's drag coefficient or drag coefficient CD. So it is according to the fluid dynamics, right? So I hope everyone is clear till this. Everyone is clear with the terminologies. Everyone is clear with the notations here. Now let's try to do some of the calculations, right? So now suppose we are going to do the calculations for our electric bicycle, because electric bicycle is very simple and kind of very easy project that everyone can perform, everyone can do with limited resources what they have and what they can do, right? So yeah, so let's try to understand. So here we have whatever values we saw, right, from the mass to gear ratio. We have actually tabulated them, or we have given them in a form of a table. Mass in kilogram, G, since it is a gear ratio, it requires no unit. Transmission efficiency, it is in percentage. Coefficient of rolling resistance, as it is coefficient, it is having no unit. Acceleration due to gravity is meter per second square. Vehicle drag coefficient, as it is coefficient, no unit. Vehicle frontal area in meter square. Density of air in kg per meter cube. Wheel radius in meter. Velocity in kilometer per hour. Alpha in degree, right? So we need all these values in these units only for our ease of calculation, right? For our ease of calculation. So let's now try to do the calculation for our electric bicycle. So right, before going further, you can note down these formulas according to these notations, according to these notations that we have used here. You can note down these formulas. So what are these formulas? These formulas are for FR. FR is nothing but rolling resistance force. Rolling resistance force, we are going to calculate it by multiplying our mass with coefficient of rolling resistance and acceleration due to gravity. Then once we find this value FR, rolling resistance force, we are going to calculate rolling resistance power from this value of FR. How we are going to do that? We are going to do that by multiplying the rolling resistance force with velocity. Velocity is in kilometer per hour. That is why we are using this 3600 as a conversion factor. So through this, we will be getting rolling resistance power in kilowatt. Everyone is clear till now? The next thing that we are going to do is to find the gradient resistance force. This gradient resistance force we will be getting in Newton by multiplying mass in kg with acceleration due to gravity with sine of alpha. Alpha is nothing but inclination angle. Please take a note here, alpha we have to take in degree, not in radian. So if my inclination is 3 degree, I have to multiply mass in kg into acceleration due to gravity in meter per second square with sine of 3 degree. Are you able to understand? Please say yes or no. Yes. So yeah, this is what we are going to get through our gradient resistance force. So this gradient resistance force, what we are getting in Newton, we will be multiplying that with our velocity to get power from it. And once we get power, we are noting down that power. And the third thing we are going to find is aerodynamic drag force. Aerodynamic drag force we are going to calculate with this formula, half into CD into AF into rho with velocity square. Half is nothing but 0.5, 0.5 into CD into AF into rho into V square. So V, since it is in kilometer per hour, we are using this 3.6 factor here, right? So that is why we are dividing it with 3.6 to get it converted into our meter per second, right? So this is what we are doing for F aerodynamic, and once we get the F aerodynamic in Newton, we are going to convert it into kilowatt by multiplying it with the velocity, and we will be getting the aerodynamic drag power. So till now what we have done, we have find rolling resistance power, gradient resistance power, aerodynamic drag power. We are going to add these three values to get total power, and once we get total power, we can divide that with efficiency just to make sure that we are considering the transmission efficiency to get the total power with efficiency. Everyone is clear? This is the procedure for each and every vehicle that we are trying to find the motor power for, right? So the same formula, the same methodology we have to follow, right? So we will be taking a live example of our electric bicycle. So you see, when we consider electric bicycle, so in electric bicycle we are considering for a single seater. There will be multiple components. Here. You see, if we consider the weight of the electric bicycle, so the bicycle assembly, it means the structure, wheels, right? The seat, handle, everything will be coming around 8 kg. Nowadays, aluminum frame is being used, so even it is coming lesser than that. So bicycle assembly is coming around 8 kg. Motor and gear, whatever the motor, gear, sprocket, whatever chain is there, it is coming around 4 kg. Controller and wiring and everything is coming around 1 kg. Battery is coming around 6 kg. Cyclist is coming around 80 kg, and auxiliary weight is 1 kg. Auxiliary is just for whatever horn or this brake lever, everything we are considering is coming around 1 kg. So total 100 kg is coming. Even you can take more than 100 kg for consideration. Let's suppose you can consider 120 kg, 150 kg as per your calculation, but the methodology or approach will remain same. Everyone is clear till this? Everyone is clear till this? Yes. So thank you, Mr. Mr. Shankar Narayan, for responding every time you respond, right? So thanks a lot for the interaction. Yeah. So like this, we have got the total weight. So this 100 is in kg. 100 kg is the weight. 100 kg is the weight. Okay. Now, if we consider this 100 kg, it will be, there are two wheels. One is front wheel, one is in the rear. So this weight will be getting distributed in front wheel and rear wheel. So in front wheel about 25% or 25 kg, and in rear wheel around 75% or 75 kg will be the weight that will be coming. So we have to see which wheel drive we have to use, front wheel drive or rear wheel drive. So for our bicycle, our rear wheel drive is much more effective, much more reliable and preferred. That is why we are going to use the rear wheel drive. So we are going to use our motor at the rear of in the rear wheel. So it is going to power, and the front wheel will also be moving with the rear wheel. Right? If we do the free body diagram, if we consider the free body diagram, we'll understand these components. So let's try to note down the the parameters here, right? Let's try to note down the parameters here. Correct? So mass in kg is 100 kg. If you have pen and paper with you, you can use your calculator also, because several calculations we are going to do in coming slides or coming time. So it will be easy for you if you note down these values. It will be helpful for you for doing the calculations related to this case study of electric bicycle. Mass in kg is 100 kg. The gear ratio, we are planning to have the gear ratio of 6:1. It's up to us. If we don't require gear ratio, we can use 1:1, right? 1, we can use 1. Mass in kg is 100 kg. Gear ratio is 6 we are considering. Transmission efficiency 90%. Coefficient of rolling resistance 0.016 we are considering. Acceleration due to gravity is 9.81 meter per second square. Velocity, vehicle's drag coefficient is 0.46. Vehicle frontal area, since it is an electric bicycle, it will not be more than 0.5 meter square. Density of air is coming around 1.225 kg per meter cube, that is constant, right? Vehicle wheel radius. Wheel radius for our scooter, for our Activa, will be around 0.25 meter. For our bicycle, it will be around 0.3 meter. So the total diameter will be 0.6 meter. Velocity here that we have to use or we are going to consider is 25 kilometer per hour. Gradient, let's try to consider 1 degree. It is up to us whatever we can consider. So for bicycle, majorly we consider 2 degree 3 degree for calculation. For a car or something like that, we consider 7 degree 8 degree maximum, like that, 10 degree for consideration for doing the calculation. For car also I've seen considering 7 degree like that for gradient, right? So yeah, here these are the parameters that we have decided for electric bicycle, So now the power that we will be getting through the calculation will be the power required to run a bicycle at a speed of 25 kilometer per hour, and that bicycle is standing in the middle of an inclination of 1 degree, having a weight of 100 kg. And with these values we are going to do the calculation, right? So the first thing we are going to find is the rolling resistance. Please find the rolling resistance. Power. And first find the rolling resistance force, CRR into M into G, and tell me what value you are getting. Yes, so 15 point something Newton, right? So that value of force, if you multiply it with velocity, we will be getting in kilowatt the power. So please do the calculation and tell me what value of power you are getting. Yes, 109 watt, 0.109 kilowatt. Correct? Yes. Yes, so this is what the rolling resistance power. Now try to find the next power, that is nothing but our gradient resistance. Gradient resistance, please find the value. M into G into sine alpha, take in degree, sine 1 degree into 9.18 into 100 kg. Please do it quickly. We have a few minutes left. Already we started 10 minutes late, like late today. Yes, please be quick. Yes, so you are getting the gradient resistance force as 170, 170 or what it is? So 17.12 Newton, right? And if you convert that force into power, you will be getting like what kilowatt? Yes, so this is what the gradient power you will be getting. Now the next thing you have to calculate is the aerodynamic. Please do that. Please do that quickly. Thank you, Shankar Narayana, for your prompt response. Yes, what value you are getting? Yes, so this will be your drag force. Convert that into power. Yes, so now we have got rolling resistance power, gradient resistance power, and aerodynamic drag power. Rolling resistance power, gradient resistance power, and aerodynamic drag power, if we add all these three powers together, we will be getting the total power. Please do that and tell me what value you are getting. Please do that and tell me what value you are getting. Yes, so 0.28 kilowatt, something like that. And if you divide that total power with 90%, like to get the efficiency, to get the total power with efficiency, what value you will be getting? Yes. So around 300 watt, around 270 to 300 watt, right? Around 270 to 300 watt is what our calculated power. Around 270 to 300 watt is what our calculated power is coming for our electric bicycle. Now, after doing this calculation for motor power, what we have to analyze or what we have to explore is what is the available motor power in the market. So in motor power in the market for our electric bicycle, the motors are available with a power of 250 watt, with a power of 250 watt nominal power, and giving 300 350 as a peak power. These are the two motors available. This is 250 watt geared motor and 250 watt BLDC hub motor, BLDC gear motor, BLDC hub motor. These two motors are available, right? Accordingly we can select. So these motor, I hope you remember we saw one thing yesterday, like when exploring the different motors. So in motors there will be two types of powers. One is the nominal power, another one is the peak power. So the peak power, the nominal power that we are getting here for these types of motors is around 250 watt. 250 watt, power of the motor, and peak we can get up to 300 350. So this motor is likewise suitable for our electric bicycle. This motor 250 watt BLDC motor is suitable for our electric bicycle, right? So yeah, so this is what we have to do, right? So tomorrow when we start, we are going to see the other parameters also. So let me come back again. So today what we have done is we have found the mass, and from that rolling resistance, gradient resistance, aerodynamic drag, we have added this value. So tomorrow we are going to see about the motor RPM, motor torque, the calculation for it, the voltage of the motor, wiring diagram, many important things, the MATLAB and many other things we are going to see tomorrow, right? Let's connect again tomorrow. So till that time, I assume that you learned something interesting today, and I hope if you have any doubt, if you have any clarification, anything, you can post in the comment box, and we'll be happy to take the questions. We'll be happy to take the questions also. Yes, please. Any question? Yes, any question? Yes, Shankar Narayan is asking about the optimum selection. So the thing is that whatever calculation we are doing is as per our design parameters, right? So when we go for our design parameters, right? So there might be value, we might be getting around 300 watt or 350 watt, but we have to see what is available in the market also, because no one is going to give a customized solution for us, right? So now once we get that, okay, we have to see what is available in the market. Let's suppose in market 250 watt motor is available, and in that 250 watt two types are available, like BLDC hub motor as well as this gate motor. So BLDC hub motor is compact and very simple. In gate motor you have to connect the chain and other things, but in BLDC hub motor it is very simple. It is already attached to the wheel. Just you have to power the wheel, power the motor, and it will run, right? So it is very simple in terms of the construction wise, right? So yeah, so like that, people or manufacturers are preferring BLDC motor, but the cost of this BLDC motor is a bit high compared to other motors, right? So according to your budget and other things, you can consider that. I hope that answers your question. So these powers that we are getting, the power that we are getting, very important question he has asked. Very important question he has asked, right? So let's understand the power that we are getting here. The power that we are getting here is the power 270 or 310 with the efficiency that we have got is the power required to run our bicycle, which is in the middle of an inclination of 1 degree with a speed of 25 km per hour. Are you able to understand? So this will be a very kind of particular case. It will be a particular case that, let's suppose we are in the middle of a hill of 1 degree inclination and we have stopped our bicycle and suddenly we have to run it at a speed of 25 km per hour with a weight of 100 kg. So in that case we'll be requiring this power of 270 watt or 310 with efficiency. So, but you see, this will be a particular case. But on the smooth road or normal road, we will not be having this inclination or this power requirement. We might be, running at 20 speed or 15 speed or 23 like that. So this will be according to our condition. So if I'm considering this condition as my peak condition, so that value will be the peak power value, right? And if my normal condition is lesser than this, right? So this will be my peak condition, right? I hope you understood. Any other question? Guna sir?
Yeah, sir. Now I check in YouTube. I think no one had asked questions in YouTube also.
Right.
I think anyone have any questions? Please post in the chat box.
I have one question for you people all. You can definitely, give your inputs. Right, tomorrow you can tell me how does this Google Maps it predict the traffic. Does Google Maps it predict the traffic? Okay, so you have to give the answer tomorrow, participant. And yeah, I'll repeat again one more time that what discussed what we discussed priorly, what we discussed priorly on Thursday, that the intention of this program is to make you think out of the box. And right, so always try for thinking out of the box. And try to innovate, keep innovating, keep thinking, have design thinking approach, have design thinking approach, right? And let me show you something interesting here.
Okay, sir. Thank you, sir.
Yeah, thank you.
Thank
You
you.
see solar diya. We made this solar diya during this pandemic time and during this Deepavali, right? So it works on the solar energy. So like that, many innovative concepts can be worked on, can be executed and all. You can definitely explore these kind of innovations. You can definitely explore these kind of innovative ideas. So you can visit to this site where you can find multiple ideas and multiple innovative projects and things done by the different people across the globe. And if you have any innovative idea, definitely you can also sign up. You can also, for it, right? Thanks a lot for your cooperation. Thank you, Guna sir.
Yeah, yeah. Thank you, sir.